You should be able to see on screen now there's like a QR code which goes into our system. So over here we've got, so for fresh graduates, which data management technical skills are most required in this new era? So one of the, there's a range of problems here. So I don't think there's actually any area that won't need some of your assistance. If you've got a bent towards infrastructure, then understanding some of these new streaming repositories and how data can be analyzed in real time will be extremely important. So as I mentioned during the presentation, we're shifting away from data analytics, which is based on structured or historical repositories, into being able to infer and to drive some of that. So if you've got an approach where you understand how to run data management in real time, that using sort of some of these, Apache Stream and some of these new sort of technologies, that's going to be extremely useful. If you've got a bent towards running algorithms and being able to optimize those for accelerators and to be able to drive that down to the edge, there's a huge amount of opportunity as we move that real-time analysis right down to the edge of the network, or in the case I just showed you, onto a drone, into a camera. That requires very highly optimized algorithms that can use the battery and power constraints of the system that sit out on the edge of the network, with the accelerators and the capability that we have to be able to create the best kind of outcomes for that. So there are opportunities across the data management landscape. The other side is around how we drive insights from that. So I mentioned dashboards, and dashboards have been something that we're starting to see most organizations. In fact, during last year, during COVID, and this year still, when the environment changed so quickly, companies really realized that the traditional method of managing businesses with reporting were no longer adequate. They needed to be able to see what was happening in real time and to be able to understand that how the changes that they were making were impacting the business that they had. So they started to move towards these dashboards. We're starting to see the next generation of dashboards looking more like an augmented reality or a virtual reality, because the data sets that we're bringing together are so complex. So being able to distill those data down into a visual that people can understand is going to be another enormously important skill. So if you've got skills and capability, or you're working along that track of how to visualize data, how to be able to present it in that way, then that would be extremely useful as well. There's another question here about how to maintain the integrity of the data obtained. So that's a really interesting question. So in fact, Dell Technologies have created some technology called Alvarium, Project Alvarium, which we've donated to the open community. And this is about solving that exact problem. So about being able to create metadata tags that can identify where that data was collected, where and when the data was collected, what device that was created from, and to be able to attach any policies to that data at the point in which it's created and every point in which it's analyzed throughout the environment. So for instance, if you're carrying a smartwatch and it's collecting health information, I want to make sure that that information is being used by my doctor and is not being used by my insurance company to be able to change how much they charge me for my insurance, for instance, or for other purposes in which I didn't want it to be used. So you need to be able to attach those policies to the data when it's created and have those policies respected, all the way through the chain of creating insight from that. So another question here for the map where we're using the drone. How long does it take the drone to get all of the data, the height of the building, etc., and to produce the 3D image? So the answer is that the images are mapped in the camera in pretty much real time. So you can kind of see a rough view of that, but then it gets transferred to a system with, this startup is still very early. Literally, there are only sort of 5 people in this company at the moment where they've invented this technology. So they then make sure that it's producing the results and outcomes from it. So within a few hours, you've got the data that you kind of see there. So there is some of it very to you in real time, but it's not as accurate as you would like it to be. Once it goes through that machine learning algorithm and it generates those the very highly accurate points that you saw, that tends to take a couple of hours to happen. So about data security. So data security I didn't even cover it in this presentation. it's another huge sort of section in and of itself. So data security is absolutely crucial. I mentioned trust, and that's one of the big elements of it. So the consumers and users of the data need to be able to trust that it's being collected and stored and protected for the purposes in which it's being used, especially with things like health data that we're starting to collect from patients. They want to make sure that it's able to be secured correctly. We're also seeing new problems arise in this. So not just issues around losing data, but cyber attacks are becoming more and more common. Unfortunately, people realize the value of this data and are finding ways to be able to get around these systems. So the reality is that it's not really when organizations are going to be compromised, or if it's going to be if when organizations are compromised. We're starting to build new systems to be able to build information into cyber bunkers that can help us recover from those kind of environments, and we're starting to drive encryption and security on individual data points at the point in which they're collected right the way through, so that they can't be misused for some of that. But data security is a very important point, and it's a whole topic in and of itself. So dealing with anomalous data for real-time systems, so that's a very interesting challenge. So we're handling this with our ADAS team. So we're doing autonomous driving systems with many of the large kind of car manufacturers. As you can imagine, within a car, you've got sensors that can tell you how fast and how hard, what angle the car is at, how much pressure is going through it, and those sensors can be damaged. So if somebody drives into a wall or into another car, there might be a few of those sensors at the front of the car that are damaged, but the other sensors might be still reporting valid data. So we've actually built algorithms that are inside the car itself to be able to take all these data points and to infer from that which ones of those sensors it should ignore and which ones correlate with the expected sort of change of the data. So being able to use that data to be able to predict which the most valuable data points are is very important. So my advice for industries that are yet unable to see the potential of analytics. So I'm struggling to see any industries that won't benefit from data. I've used some use cases throughout this presentation, and everything from farming through to manufacturing, through to high tech, through to retail, logistics, manufacturing. There really aren't any industries that aren't going to need to use it. There are some that are slower than others. So, there are some traditional industries that haven't been well instrumented. So retail, for instance, is one of those, where it has taken a long time to be able to instrument some of those environments. We're now building camera systems that can do customer mapping through stores to be able to show where people travel. We're doing fraud and loss prevention. So we're able to see, for instance, with self-checkout technology, be able to detect exactly what people have put into their trolley, so that we can automatically bill them as they kind of leave the store. So that relies on high definition multiple point cameras that are analyzed through storage processes that are in the store itself to be able to map those images and be able to accurately tell what goods and services they've predicted. So almost every industry is going to be impacted by this. There are a few that are still to see much of that, but I think those will continue to evolve. And digital twins help with forecasting and combating climate change. So climate forecast has been one of the earliest views of digital twins, and it's actually one of the most challenging problems. So the amount of data and the complexity of how weather changes over a landscape and how we've changed that environment by building cities with reflective surfaces or changing that has had a massive impact on the weather. So there are some very large models. It's, in fact, in New Zealand, we've just built a new supercomputer in partnership with NVIDIA to be able to do weather modeling and to help improve what that kind of looks like and help predict what the future means in terms of climate change. One of the biggest problems that is facing us as a society, and is one that we are putting a lot of time and effort into helping to resolve that. So where will digital twins and be in the grand scheme of blockchain or hash graph technology? So blockchain is very interesting. We went through this kind of hype a couple of years ago of blockchains being used to try to simulate logistics and supply chains and places that it really didn't need to be. That's now coming back to being used in models where where it's much more effective. I mentioned during the presentation, being able to connect up and down the value chain with different, different suppliers and producers as you're supplying those. Blockchain is a perfect technology to be able to use to connect and share that data in a way that's applicable with that. What you see happening is that those different companies throughout that value chain will collect their own sets of data and they'll want to sell that to other elements within that value chain. So they want to be able to create another revenue source from that. That means being able to share it in a way that allows them to bill for that data as it's being shared and as it's being used and as additional value is being created from that. We're seeing blockchain be used to store that data, to be able to create the policies around that data and to be able to measure and monitor when that data is being used. So it does have a big role to play in that side of the environment. So what's my advice for startups who are planning to venture into these areas? So much of this landscape is yet to be solved. So for startups have a unique advantage in that they can find a problem and maniacally focus on being able to solve that problem. And they really, the piece that I look for with startups is being able to have a talented team that understands the problem that they're trying to solve, and that they're very connected with their customer and taking that feedback to be able to evolve their solution. So the best startups are the ones that can use the data, generate new versions of their product, measure the impact of that, and then drive back through that circle as fast as they can, constantly testing that with your customer to make sure that they're solving the problem that they need solving. Which tech and which area could be of a good value? So I think there's opportunities all over the place. As I mentioned, there's opportunities in the edge architectures with the cameras that are kind of being built. There's also opportunities in terms of the way that those workloads are being distributed onto edge architectures with container management solutions that are being used to distribute that. So there are lots of opportunities all over the place. My opinion for companies using Power BI for data analytics. So Power BI is one of the standard tools that are quite well used. It's very valuable to be trained and to be competent in that. That's being used by many industries, and it's a very adaptable and powerful tool to be able to visualize data. As I mentioned through the presentation, the type and complexity of data that we're trying to visualize and understand the impact of that, and the second, third, and fourth order impacts of that data as changes are kind of made from it, make it very challenging to present in a traditional way. So tools like Power BI and being able to build some of that out are really making a difference in how we can build that. Is there any solution if there's a breach of cyber attack? Well, the answer to that is it depends. So unfortunately, we kind of need to take a view where we're trying to secure the way that we interact with the world as well as the way that we protect the information that we're storing. I mentioned sort of cyber bunkers. That's a relatively simple addition to many companies' architectures that gives them a guaranteed method of being able to recover it. We saw a large preponderance of sort of attacks recently that will look at encrypting a company's data, and generally those attacks start to encrypt the backups first, and then they'll encrypt the production facility. So when companies try and use the backups to recover their data, they find the backups are no longer relevant. So having a secure repository that's disconnected from the production environment means that sort of those types of cyber attacks don't impact that data. How does data help in making decisions for designing curriculums accordingly? So yes, universities and higher educations are really changing the way they operate for a number of reasons. And so we are seeing the traditional kind of 4-year degree that sets you up for a career starting to turn into something where you're having to come back to university and share the learnings that you've made in business, and then retrain to be able to launch something. So the technology is changing so quickly, and the methodologies by which we use this information to create value, you end up having to come back into university. I myself at the moment am going through a course at Stanford to refresh my skills and to be able to take advantage of that. So I think we'll see an environment where people sort of dip in and out of university over their career rather than only spending the time at the beginning of their career in that. And data is a huge part of that. The course that I'm doing at Stanford is very data-driven, it's very research-oriented, and it's often that we are doing that research in real time. So the teams that I'm part of through the university course are actually performing that research inside of our own organizations, providing that back, and then applying the methodologies and the teaching to that research as we kind of go on. Can I explain a little bit more on the algorithm used by Sky? So Sky used a little bit of that sort of supply chain integration to be able to tell where broadcast and telecommunication impacts were affecting their customers' consumption of and then be able to bring that back and surface that to customers directly through the chatbot tool. So kind of a couple of areas there. One, the chatbot was being used as a method of interacting with customers in real time rather than a call center, although the call center is still available. So if those customers that did want to ring and talk to an actual human, they could do that, or they can use a voice AI bot to be able to chat to, or they can use the text bot to be able to say, hey, what's going on? My coverage seems to have fallen out, and it would use that information in real time to be able to tell where that was potentially impacting and help customers to resolve that. So for instance, if it's a single customer with a challenge, the problem's more likely to be on their side. If it's a group of customers across an area, they can quickly sort of forecast to those about what's going on. So transforming agriculture to AI, how does AI help to generate the data? So AI is not generating the data, AI is being used to create insight from the data that's generated, although you can use AI to create models. So you can use AI to generate data sets that you can use for training, for predictive kind of inference, so it could be used in that way. But generally, AI is being used to process the data and to be able to create insight and predict the future from that. So I think we've run out of time, so thank you for all your questions. Thank you for your time today, and really appreciate the opportunity to be able to speak to you.